Hello and welcome to section 7.1, adding and subtracting polynomials. Before we get to the actual adding and subtracting, we have some things we need to define starting off. The first thing we start talking about is what we call a monomial. A monomial is a number, let me fix that. Is a number, variable, or the product of a number and one or more variables. Sorry, I ran out of room there. All right, so the monomial is just a number, a variable, or the product of a number and one or more variables. Okay. The degree of a monomial is the sum of the exponents of the variables. All right, so if it's just a number, so if it's just a constant, we don't need to worry about that. But if it has any variables, we add up the exponents, and that will give us the degree of a monomial. Okay, so just a quick chart here that shows you monomial, right? If it's just a constant, it's degree 0. All right, and that's just because if we put an x with this, remember x to the 0 equals 1. So this could really also be written as 10 to the x times 0, which is still 10. That's why the degree is 0. The second one, its degree is 1. The third one, there's a 1 with this a, there's a 2 with the b, that's why it's 3, and the last one's 5. Okay. Some reasons why stuff's not a monomial. All right. The first one isn't because there's 2 terms. All right. The second one isn't because there's a variable in the denominator. A monomial cannot have a variable in the denominator. The third one is we have a variable exponent. That's like what we're doing in the last chapter, but that makes it not a monomial or a polynomial. And the last one's because it has a negative exponent, which isn't a whole number exponent. All right. So a couple quick examples here to show you the degree of a monomial. All right. The first one is 1. Remember, this y really has a 1 with it. Our second one is 4. All right. Now our third one here, we have to be careful. We're going to do 3 plus 2 because we have to add up the exponents of both of the variables. So number 3 is 5. And number 4, remember, any constant, like our example up here, is 0. Okay. All right. Some more definitions, and then we'll get into adding and subtracting. A polynomial, all right, I'm going to start up here just in case it goes a little bit long, is a monomial or the sum, means adding, of monomials. All right, and I'm just going to add underneath it, each monomial is called a term. All right, remember, a term is separated by addition and subtraction signs. All right, so that we're going to add up all the monomials, and that will tell us how many terms we have. So the first one is a binomial. That would be 2 terms. All right, the example 5 plus x at the top is a binomial. All right, the next one is a trinomial, which is 3 terms. All right, and a polynomial is 1 or more terms. All right, so technically, every monomial is a polynomial. All right, every trinomial is a polynomial, and every binomial is a polynomial. Just once we move forward, as we start worrying about classifying it, we more just talk about polynomials, and that can be 1 or more terms. Okay, standard form of a polynomial, we always want to write these in it first, is when the exponents decrease from left to right. Right, we want the highest one all the way to the left and keep going down in order all the way down to our constant or our 0 exponent. All right, the degree of a polynomial is the highest exponent when written in standard form. All right, and the leading coefficient, I like to use LC, all right, is the coefficient of the first term in standard form. All right, so notice standard form is important that we write them in this. Okay. Oh, sorry, I'll move that down. I don't know if you can see that, but all right. So now as we go through it, we're going to go through and we have a couple of examples. We have first our example here. All right. This first arrow is pointing to the 3. All right. And before I even start that, notice this in standard form because our exponent's 2, then 1, and then a 0. So the 3 in this case is our leading coefficient. The 2 is the degree. And the 15 is a constant. Remember, a constant is just a number. It doesn't have a variable with it. Okay, so that's just kind of a refresher. All right, make sure we remember what all these different things are. Okay, so now we look at it here. It's going to say, write the following in standard form, then identify the degree, leading coefficient, constant, and type of polynomial by the number of terms. All right, so the first thing we need to do is write it in standard form. So I need to rewrite this one as negative 9z plus 4. When we write it in standard form, remember, all of the signs that are in front of the coefficient go with it. That's why it becomes negative 9z plus 4. All right, so in this case, our degree is 1 because the z has a 1 exponent to it. Our leading coefficient is negative 9. Our constant is this number at the end, which is 4. All right, and then the type by the number of terms, well, we have 2 terms here, so this is a binomial. Okay, as we look at the second one, we once again need to start off by writing it in standard form. Our highest exponent here is to the third, so we'd say negative t to the third. Then we have a positive t squared minus 10t. Okay, so our degree is the highest exponent, which is 3. Our leading coefficient is negative 1. Our constant, there is no constant here, so it's 0, right? We could write plus 0, but we don't need to. And the type is there's 1, 2, 3 terms. So this is a trinomial. All right. Once again, number 3, we start off by writing it in standard form. So we'd have x to the third plus 2.8x. All right, now that it's in standard form, we look to the first exponent here, the highest exponent, which is 3 again. The leading coefficient would be 1, because remember there's a 1 out in front of this x that we don't have to write. The constant, again, is 0. And the type is a binomial. Okay. All right, so that's just some practice naming the degree, leading coefficient, writing them in standard form. All right, so now what we're going to do is we're going to start by adding and subtracting some polynomials. All right, when we add and subtract polynomials, all we're doing is combining like terms. Okay, so if I look at the first one, what do I have that has a b with it? Now notice it says, let me take a step back. Notice it says find the sum. We always want to look at this middle sign to tell us what we're going to have to do here. All right, if it says find the sum, it's addition. All right, but it's very important we pay attention. So we're going to add these like terms. Well, what's b plus 4b? 5b. And then we would do negative 10 plus negative 3, which is negative 13. All right. For the second one, what I want to do to start off is I want to write it in standard form. This first part's already in standard form, but my second parenthesis isn't. So I'm going to rewrite it as 5x squared plus 2x plus 1. Okay. Now I'm going to combine my like terms. 3x squared plus 5x squared would be 8x squared. 4x plus 2x, which is 6x. And 3 plus 1, which is 4. All right. Now, please understand something. If you feel confident, you don't need to go through and rewrite it in standard form. You just need to look at the like terms. We would have our 3x squared and our 5x squared. We'd have our 4x and our 2x. And we'd have our 3 and our 1. So you'd still get the same answer, all right? But sometimes it's easier for some people to write it in standard form, okay? Number 3, they're both in standard form, so we're just going to combine our like terms. All right, if we did negative 5x squared plus, or sorry, negative 5k squared plus 2k squared, that would be negative 3k squared. A positive k plus a negative k will cancel out, and 2 plus negative 9 is negative 7. And that's our answer for number 3. Okay. We want to make sure we really pay attention to the signs here, all right? Because sometimes things will cancel out and sometimes they won't, but we want to make sure we carry the signs with us. All right, example 4, the highest exponent we have in each of them is squared, so 4x squared plus 7x squared is 11x squared. All right, negative x plus negative x, be careful here, that's negative 2x, all right? And then minus 2, because there's no constant in the second one. So there's our example, or answer for example 4. Okay? So now notice, all of these said find the sum. Remember, sum is the answer to addition. All right, now for the last one here, it says find the difference. The difference is going to be subtraction. So, at the top here, there's note. When we subtract polynomials, we're going to use the distributive property, aka keep, change, change. All right, some of you know keep, change, change. All right, but I'm going to show you why. It's really just the distributive property. All right, so what we would do is we would keep the first parenthesis the same, and now we're going to distribute this negative to each term. All right, so we're going to change it to addition. And now we'd say negative 1, right? We're going to distribute the negative 1 times 6y is negative 6y squared. Negative 1 times 4y is negative 4y. And negative 1 times negative 2 is positive 2. All right. Now, instead of being the difference, this is really just the sum. Right? The sum and difference are very similar. They're just adding the opposites. So now that we have addition, we're just going to combine our like terms. Our y squareds would be 3y squared plus negative 6y squared, which would give us negative 3y squared. All right, now I look for a y. Well, this first one doesn't have a y, so we just keep the sign of the second one, so it would be negative 4y. And then our constant would be 8 plus 2, which is 10. Okay. Please make sure you do use the distributive property or keeps, change, change here, because what happens if you don't a lot of times is students only distribute to the first one and forget about the next two terms. Okay, so that's why I like to do it to all three to show you in the beginning. All right, number two for example 4 here. I'm going to keep the first parenthesis the same. Now I'm going to distribute the negative 1 and change the sign. So I kept it, I changed it. And now I'm really going to change all of the second signs. So this would be a 4w squared minus 3w plus 1. Okay. Now the hard work's over. Now we just need to go through and combine our like terms. 12w squared plus 4w squared, 16w squared. 5w plus negative 3w would be positive 2w, and negative 7 plus 1 would be negative 6. Okay. All right. So now our last one here. Example number 3 for this part. All right, so we're going to keep the first parenthesis the same. Change the middle sign to addition. and change all of the signs in the second parenthesis. Now this one's tricky because we don't have a lot of like terms here, but we want to save ourselves some steps and start off by writing it in standard form. If we look at all of our terms here, the highest exponent we have is squared, right? So we would have negative 3p squared. Now if we look, do we have any just p's? Yep, we have one. It would be negative p. All right, and now we look at our constants. Well, 5 plus 6 is 11. All right, so that's the video for lesson 7.1, adding and subtracting polynomials. Please make sure you're paying attention to the sign in between the parentheses to see if it's addition or subtraction. All right, we'll do some more examples in class tomorrow. If you have any questions, please let us know. Have a great day. Bye-bye.